The universe has always jealously guarded its secrets, especially about the existence of extraterrestrials. As humanity, we have done and continue to do everything we can to unravel these mysteries. Our thirst for knowledge has revealed much, and with the James Webb Space Telescope in our arsenal, the possibilities are endless. In a recent breakthrough, the James Webb Space Telescope sent back new high-definition images of Proxima B, a world believed to harbor extraterrestrial life outside our solar system. These images showed something surprising and extraordinary, fueling our search for habitable exoplanets and the potential for extraterrestrial life. The universe formed about 13.8 billion years ago and has evolved into what we know today. Planets and moons emerged, establishing dynamic and ever-changing relationships. Since humans began observing the night sky, we have sought to understand this cosmic relationship, using our ingenuity to develop advanced tools to aid us in our search. The James Webb Space Telescope, JWST, the most advanced to date, acts as our eyes to investigate celestial objects and events. It has allowed us to explore the depths of space and improve our understanding of the universe. Its infrared capabilities revealed previously unknown cosmic features, investigating the origins of galaxies, stars, and planets, and searching for signs of extraterrestrial life beyond our solar system. Equipped with sophisticated filters, the JWST has allowed scientists to map the cosmos, detecting various features and mysteries that previously telescopes could not. Although we have not yet realized its full potential, the JWST discoveries have been astonishing and promise to revolutionize our understanding of the universe. For example, it has been discovered that the universe has a greater mass than previously thought. With each discovery, the James Webb Space Telescope, the JWST, unravels the mysteries of the cosmos, revealing its secrets galaxy by galaxy. However, the story does not end there. Recently, the James Webb Space Telescope has achieved a new feat by sending the first clear image of Proxima B. This discovery dates back to 2013, when scientists detected a slight gravitational pull between planets and its parent star, called Proxima B. This celestial body is a planet that orbits Proxima Centauri, the closest star to our Sun. This discovery was exciting news for the scientific community, as it was like finding a new neighbor in space. Proxima Centauri is part of a system made up of 3 stars and is only 4 light years away from Earth, making it the closest star to our solar system. Although Proxima B appears to be 25 light years away, it is actually one of our closest planetary neighbors beyond our solar system. Imagining the possibility of traveling to a newly discovered world so close to our own is fascinating. This exoplanet is slightly larger than Earth, with a mass of about 30% greater than our own home planet. However, what really captures the imagination is its extreme fast orbit, completing one cycle in just 11.2 Earth days. This rapid evolution of Proxima B is due to its close proximity to its parent star, orbiting about just 7.3 million kilometers, a relatively short distance compared to the distance between the Earth and the Sun. Scientists expected Proxima B to be scorching hot. Hot because its star is small and emits much less heat than our Sun. Proxima B's surface is not as hot. Instead of a bright sun like ours, Proxima Centauri would appear as a faint crimson sphere with a diameter 3 times that of the Sun. Additionally, if Proxima B is in its star-habitable zone, known as the residual zone of Oro, where temperatures are neither too hot nor too cold, the data suggests that there could be water on the planet. The possible presence of water on Proxima B has sparked great interest in the scientific community, as this could mean that the planet could support life. Scientists are eager to learn more about this mysterious planet. However, some significant concerns temper our interstellar aspirations. One is that Proxima B could be trapped in a state known as tidal coupling, where one side always faces the star while the other remains in perpetual darkness. This fact is not favorable for the development of life. Additionally, there is a big problem with water turning into steam. If there is water near the star, it will heat up quickly and will turn into clouds of vapor. On the other hand, if a planet moves too far from its star, it will become extremely cold, making the existence of liquid water impossible. But that's not all. Although Proxima Centauri is much smaller than our Sun, it has a stormy core that creates strong magnetic fields. These fields release a lot of radiation and bursts of cosmic particles, posing formidable challenges for planets located within the habitable zone of stars, such as Proxima B. Therefore, the possibility of life is minimal. Until recently, scientists didn't know much about the magnetic field around Proxima Centauri, but with the new technology, they have learned a lot. A recent study found that Proxima B receives a lot of radiation from the star's solar wind, 1,000 times more than Earth. This enormous amount of radiation makes it difficult for any form of life to survive. An example of how wild this environment can be was seen when Proxima Centauri released a massive burst of energy called the mega flare, 100 times larger than any solar flare of our own Sun has ever seen. This giant explosion in space further reduces the possibility that Proxima could host life, despite the exciting idea that it could. The conditions around Proxima B are probably too harsh for any life form we know. Interest in this planet peaked in late 2020 when scientists detected a strange signal coming from the Alpha Centauri region, where Proxima Centauri is located. The intriguing thing about this signal is that it has a frequency of 982.551 MHz. New discoveries from the James Webb Space Telescope, the JWST, have revealed something fascinating. The data suggests that Proxima B could have water vapor in its atmosphere. This finding is very important because water is crucial for the existence of life. Determining how much water there is in Proxima B is like solving a big space puzzle. Scientists are using advanced tools such as spectroscopy and atmospheric modeling to learn more about Proxima B's atmospheric composition. Spectroscopy is a specialized tool that helps scientists identify the gases present around Proxima B. This technique reveals important atmospheric compounds and their composition, such as oxygen, methane, and carbon dioxide, which are essential ingredients for life. Another useful tool is atmospheric modeling, ATM, which creates a computer model of what Proxima B's atmosphere could be. Scientists can adjust different scenarios and variables, similar to how a dinosaur model is made, to imagine what it was like when it was alive. This technique helps us unravel the mysterious veil covering Proxima B's atmosphere and determine whether it could be a suitable place for life. As we move forward, there are still many unknowns, so it is essential to continue exploring and learning about this planet. Despite the harsh conditions surrounding the star Proxima Centauri, scientists are hopeful of finding inspiration on Earth, where there are tiny extremophile organisms that can survive in places previously considered impossible. These organisms are found in hydrothermal vents in the deep ocean, in highly acidic lakes formed by volcanoes, and even in the frigid cold of Antarctica. Their ability to thrive in unexpected environments demonstrates incredible adaptation and resilience. Given the astonishing resilience of life on Earth, the idea of finding life on a planet like Proxima B seems increasingly plausible. Extremophiles have expanded our understanding of where life can exist, challenging what we thought possible by surviving in places that seemed uninhabitable. This gives us hope that similar life forms may exist on distant planets like Proxima B, which are being actively studied. Proxima B is an Earth-like planet orbiting the closest star to our solar system. What a coincidence! Although conditions on Earth are quite suitable for life, why settle for that when there are other planets that offer better characteristics such as balanced temperatures, fewer deserts, and a greater abundance of water? We're talking about the future of humanity, and scientists have identified some planets as prime candidates for possible colonization. These super-habitable planets, as Michio Kaku calls them, are fascinating and pose exciting possibilities for our future. Michio Kaku, the renowned physicist and co-founder of string theory, is optimistic about the future of humanity and the possibilities and opportunities that these super habitable planets may offer. He firmly believes in the possibility of achieving immortality and, furthermore, aspires that in the future we will be able to colonize other planets and even entire universes. This idea arises due to the need to have settlements in places in case of something catastrophic happens on Earth, such as meteorite impact, supervolcanoes, or ice ages. In about 5 billion years, it is even predicted that the Sun will expand and consume Earth. The first steps to ensure our survival is to leave Earth and start colonizing other planets in our galaxy. The goal is to find Earth-like planets or even better planets called superhabitable planets that have even greater potential to harbor life than our own home. The term superhabitable planet was proposed in 2014 by Reid Heller and John Armstrong. According to them, the mere location of a planet within the habitable zone of its star is not enough to determine its actual habitability. Superhabitable planets are specific celestial bodies that offer a higher potential for harboring life compared to Earth. The common belief is that the Earth, as we only known planet with life, meets the psychochemical parameters necessary for the development of life. These parameters are key to life as we know it, and one of the essential elements is the presence of liquid water. It is for this reason that we search for exoplanets similar to Earth, in the hope of finding places where life can also exist. However, it is important to recognize that other types of planets may offer conditions equal or even more conducive to life compared to Earth. Contrary to the notion that Earth represents the pinnacle of planetary habitability, a superhabitable world could also be a mood with a richer range of flora or fauna compared to our own planet. Such a world would be shown as a higher degree of environment conducive to life. It is also important to note that not all rocky planets located in the habitable zone of a star are automatically habitable. Habitability depends on a variety of factors and is not limited solely to similarities with Earth. The concept of superhabitable planets can be complicated to convey as it challenges the assumption that Earth represents the pinnacle of planetary habitability. However, it is important to consider that our planet harbors an impressive array of complex and diverse life forms, suggesting that life can thrive in conditions very different from those on Earth. In the search for exoplanets, research needs to explore indicators that may reveal the existence of superhabitable worlds. Among the promising targets, Alpha Centauri B has emerged. Alpha Centauri B is part of the closest star system to our planet, which makes its potential exciting. However, so far, no planets have been confirmed to be present in this system, much less superhabitable planets. While there was a possible detection in 2012, it was refuted in 2015. Therefore, we do not yet know of any worlds in Alpha Centauri B. However, its neighbors, such as Proxima Centauri, are of special interest. Proxima Centauri is a red dwarf located only 4.2 light-years from Earth, making it an intriguing candidate to host not only habitable planets, but also possible superhabitable planets. Within the Proxima Centauri system, an exoplanet called Proxima Centauri B has been identified as a residing in the red dwarf's habitable zone, along with other contending candidates such as Proxima C and Proxima D. Proxima Centauri B is one of the closest known exoplanets to our solar system, which has led to the question of whether this planet could be habitable. However, there are significant obstacles to life thriving here. Several variables complicate the habitability of Proxima Centauri B, such as the activity of the host star and tidal locking phenomena. The light emitted by Proxima Centauri is comparatively redder, which could reduce the interactions with certain organic compounds and decrease ozone production in the planet's atmosphere. This in turn could generate elevated levels of UV radiation harmful to life. In addition, Proxima Centauri B's orbit may be eccentric, which means that in certain parts of its journey, the planet could temporarily fall outside the habitable zone. These fluctuations could negatively affect its habitability potential. Another factor to consider is the presence of carbon monoxide in the planet's atmosphere. If these gases accumulate in excessive amounts, they could become toxic to living organisms. On the other hand, if Proxima Centauri b were to host oceans, higher oxygen concentrations could have a positive effect on the evolution of complex organisms. Tidal forces, due to tidal locking on this planet, would generate periodic cycles of flooding and drying in coastal landscapes. These cycles could trigger chemical reactions conducive to the development of life and promote the emergence of biological rhythms similar to the natural cycles we observe on Earth. In addition, similar cycles of flooding and drying would facilitate the mixing and distribution of nutrients in the oceans, stimulating periodic expansions of marine organisms, akin to what we know as red tides on our planet. It is important to mention that although red dwarfs, such as Proxima Centauri, are exceptionally long-lived compared to our Sun, their radiation is not conducive to photosynthesis as we know it. However, Proxima Centauri b might be able to support a different type of photosynthesis called anoxygenic, although its possibility is not yet fully confirmed. A 2017 study suggested that photosynthesis-based ecosystem on this planet could be about 20 times more productive than the one we find on Earth. The stability of the planet's atmosphere is a major challenge to its habitability. Even before Proxima b was discovered, researchers had been actively searching for exoplanets in the vicinity of Proxima Centauri. In the research conducted in 2008 and 2009, the lack of larger-than-Earth exoplanets in the habitable zone around dwarf stars, which include Proxima Centauri, was noted. Although these stars have on average 1 or 2 planets, only 20% to 40% of red dwarfs harbor planets in their habitable zones. Therefore, our search for a habitable planet in the Alpha Centauri system has not yielded many results so far. While it makes sense to search for exoplanets in the Alpha Centauri system, since it is the closest star system to our home, there are many other options in the vast expanse of our galaxy. So far, more than 5,000 exoplanets have been confirmed, and there are countless candidates awaiting new observations for verification. Immersing ourselves in the vastness of the universe, we humans have always questioned the possibility of whether we really are the only species to habit a planet. Gazing at the stars, contemplating distant galaxies, and exploring the potential for life beyond our little blue planet. That potential has finally materialized. NASA's director has just announced that the James Webb Space Telescope has captured something extraordinary at the edge of our cosmic neighborhood. The James Webb Telescope has once zeroed in on Proxima b, the closest potentially habitable exoplanet to Earth. We recall that a possible city created by intelligent life had been detected, which, to date, we do not know. The recent James Webb discovery shows how the brightness of the artificial light of the city of Proxima b has increased. In addition, the chemical composition of the atmosphere of this exoplanet has been discovered. So join us to this incredible journey to Proxima b to discover the details of this discovery. According to NASA's director, the James Webb Telescope may have used all this technology effectively and has detected life on Proxima b, an exoplanet located just 4.24 light years from our solar planet. Proxima b has become a phenomenon of fame due to its potential to be habitable. This exoplanet orbits its parent star, Proxima Centauri, a red dwarf that is much smaller and cooler than our Sun. Discovered in 2016, Proxima b lies in the star's habitable zone, also known as the Goldilocks zone, which is the region around the star where conditions could allow the presence of liquid water, a crucial ingredient for life as we know it. Proxima b's proximity to Earth and its location within the habitable zone has generated enormous interest and speculation about its ability to support life. However, it is important to keep in mind that the habitability of an exoplanet is a complex puzzle involving numerous factors. Proxima b is classified as an exoplanet with a mass approximately 1.3 times that of the Earth and has an orbital period of approximately 11.2 Earth days, meaning that it completes one orbit around Proxima Centauri in that time. However, things are not as simple as we may think. The fact that the planet is Earth-like in size and orbits a red dwarf does not guarantee that it is an exact replica of our world and that we can all move there. The habitability of Proxima B is determined by multiple factors. One of them is the planet's atmosphere, which acts as a protective shield and plays a crucial role in regulating temperature and life in general. However, the exact composition of Proxima B's atmosphere is still unknown, making it difficult to definitely determine its habitability. Scientists are working on methods to study the atmosphere of Proxima B, and a key tool in this process is the James Webb Space Telescope. This telescope will allow scientists to analyze the light that passes through the exoplanet's atmosphere during transits, which will give them information about spectral characteristics and help them search for possible biomarker molecules that could indicate the presence of life. Another important factor affecting habitability is the presence of water. Although Proxima B is within the habitable zone, it is crucial to determine whether it has a sufficient amount of water to be considered suitable for life. Water is a critical piece of the puzzle, and scientists are looking for signs of liquid water on the planet's surface, whether in the form of oceans, lakes, or rivers. These clues could be key to assessing the possibility of habitability on Proxima B. The presence of water in other states, such as ice or vapor, it is also considered because water availability is essential to support biological processes and is considered a key indicator of habitability. The presence of Proxima B raises questions about its climate. Scientists must also investigate factors such as temperature, pressure, and geological activity on Proxima B to assess whether the planet is within a suitable range for life to thrive. Extreme conditions, such as a scorching heat or extreme cold, can make survival difficult. Stability is also crucial. Volcanic eruptions or seismic activity can disrupt habitability, but stability is a good sign. Proxima B is believed to be in a tidal locked state, meaning that one side of the planet remains permanently in darkness, while the other side is permanently illuminated by the star. The star contrast between the illuminated dark sides could generate temperature variations and dynamics that could affect the planet's habitability. These are just some aspects that scientists are considering in the search for habitable planets. Scientists are investigating the chemical composition of Proxima B to analyze the presence of organic compounds, such as amino acid and other molecules essential for life. They are also examining whether the planet receives enough energy from the star or other sources to fuel biological processes and allow organisms to grow, reproduce, and thrive. However, despite all these studies, the question arises as to whether Proxima B actually possesses all the necessary elements to be considered a habitable planet. Is there concrete evidence for this? Well, the discovery of Proxima B in 2016 was a remarkable achievement. Astronomers used the high-precision instrument called the High Accuracy Radio Velocity Planet Searcher, or HARPS for short, to detect the subtle gravitational tug of an exoplanet around Proxima Centauri, our nearest neighboring star. This high-precision spectrograph is designed specifically to detect exoplanets and operates at the La Silla Observatory in Chile. It has been crucial in the discovery of numerous exoplanets, including Proxima B. The HARPS instrument operates using the radio velocity method, also known as the Doppler spectroscopy technique. Its function is to detect exoplanets by measuring the subtle shifts in the star's spectrum caused by the gravitational pull of an orbiting planet. These shifts, known as radio velocity or Doppler effect, occur due to the slight wobble of the star as it is dragged by the gravitational interaction with its companion planet. HARPS has an optical fiber that collects the light from the target star and directs it to the internal spectrograph. Inside the spectrograph, the light is dispersed into its different wavelengths, allowing astronomers to study the star's spectrum in detail. In this way, scientists can determine the star's radial velocity with exceptional accuracy. To achieve the high level of precision required for exoplanet detection, HARPS uses technologies and techniques that include a temperature-controlled environment. This allowed stabilizing the instrument and minimizing the effects of thermal variations that could interfere with accurate measurements. What do you think about Proxima B? Do you think it is habitable and that in the future we will be able to move to this amazing exoplanet? Let us know in the comments box. Thank you very much for watching the video. Remember to like and subscribe, and I'll see you in the next one.